Okay, so in the following experiment, we are going to be titrating the acetic acid found in taco sauce. This is experiment 11 from the General Chemistry Lab Box Kit. So first and foremost, before we do anything, before we're able to do anything, we first have to take our 0.2 molar sodium hydroxide, 30 mils, and we have to make 0.1 molar. So to do that, we're going to do a 1-to-1 dilution. And though this is not the most accurate dilution for sure, it'll provide us an approximately 0.1 molar solution. So to do this, we're going to fill our graduated cylinder to the 30 milliliter line. And we're going to check to make sure that the bottom of the meniscus is at 30. Once we've done that, we are going to pour the contents into our bottle to dilute our contents to 0.1 molar. Okay, perfect. So now that we have our 0.1 molar solution, we're just going to mix our solution. And we'll set this off to the side. Now we're going to prepare the actual solution that we are titrating, which is our 1 milliliter of taco sauce. So what we're going to do is we're going to get out our balance, and we're going to place a 250 milliliter beaker on the balance and then tare that balance. So now we're going to take only 1 milliliter of our taco sauce. So we only need a really small volume. So we're going to use our calibrated pipettes to dispense to the 1 milliliter line, which is about right here. So we're going to dispense 1 milliliter of taco sauce into our beaker and record the mass of the taco sauce. So what I'm going to do is I'm going to very carefully cut an opening into the taco sauce container. I'm going to then pipette out. Let me cut a wider opening. Just cut the cap off. There we go. Okay, so here's our taco sauce. Now let's pipette 1 milliliter of our taco sauce. It just has to be approximately 1 mil. So here we go. We have approximately 1 ml of taco sauce. We're going to transfer it to our 250 milliliter beaker. And now the volume isn't as important as the mass of taco sauce. So we'll leave our taco sauce and our pipette for the taco sauce off to the side. And now what we're going to do is we're going to record the raw mass of material that we're titrating. Here we go. So we have 0.8 grams of taco sauce. And this is important because we're going to use our total mass to figure out the mass percentage of acetic acid, which is the acidic component of taco sauce, in taco sauce. Okay, so continuing on, what we're going to do now is we're going to remove the beaker from the scale. We're going to set our scale off to the side. And then we are going to now dispense. Oops. We are going to now dispense 20 milliliters of deionized water. The exact volume doesn't matter in a titration of extra deionized water added. The only thing that matters is the moles of acidic component added and the moles of basic component added. So now we're going to dilute our taco sauce with deionized water. Okay, and you can smell the acetic acid from here almost if you're working at home with your boxed kit. Okay. And now what we're going to do is we're going to mix our solution by taking a pipette, and we're going to pipette the solution until we have a nice homogeneous solution. Or as homogeneous as we can get it. So we want it to have as consistent of a composition as possible throughout. Okay. And we'll leave this mixing pipette to the side. Now what we're going to do is we're going to set up our actual titration apparatus. So you're going to need your ring stand. I'm going to unhook our, and now we are going to get our syringe clamp. Okay, and now once we have our syringe clamp out and ready to go, we're going to clamp our syringe clamp to our ring stand, or sorry, to our clamp holder. Okay, make sure that all of your connections are tightened. Okay, and now what we're going to do is we are going to prepare our buret in this experiment. And in order to prepare our buret, we're going to use our syringe. So first things first, let's open up. So let me move this a little bit back. Here we go. So here's our clamp. Okay, so now we're going to take our syringe. Here's our syringe. That'll be our buret for this experiment. And we have our stopcock, which controls the flow of liquid. So we're going to open up our syringe. And then you're going to remove the plunger. So you're going to get rid of the plunger. Keep it off to the side just for later. Now what you're going to do is you're going to take your stopcock out of the container and you're going to carefully thread it onto the end of your syringe right here. I'll show you how to do that once I get the bag open. Okay, so here's our stopcock. Has an open and close function. And now we're going to thread the stopcock onto the end of the syringe via rotating clockwise. And you want to make sure it's nice and secure. So it should be completely threaded on. Again, just to show that, you're going to twist it to the right until the stopcock is completely secure. So if you've done everything correctly, you should have your syringe barrel with the stopcock at the end clamped onto your ring stand. Oops. And you want to make sure it's secure and nothing moves and all of the joints are secure. Okay. There we go. Okay. Let me just rotate it so that way we have the milliliter volumes in the camera. So the stopcock can open and close. I'd like you to have it perpendicular to the opening. So I'd like you to have it horizontal. Has everyone gotten their syringe set up? And as one final touch, you're going to put your funnel on top of your syringe. So it should look like this when you're done. Does that make sense to everyone so far? Is everything going okay so far? Can I get some responses in the chat that everything's going okay? Can I get some responses that everyone in the class who's following along with their lab box is at this stage in their procedure?
Yeah.
Okay, perfect, perfect. So let's just clear out some space. Let's clear out some space. So now for this next part, we're going to take our 100 milliliter, sorry, in this case, we'll use a 50 milliliter beaker, and we are going to condition our pipette. We're going to condition our buret. So in order to condition our buret, what we're going to do is we are going to transfer a small volume of sodium hydroxide through our buret. Now it's really important. Anything that exits our buret when we're conditioning is waste. So we're just going to rinse our buret with a small volume of sodium hydroxide. So we're going to do 2 small volumes. Just a very, very small amount. So we have our small volume of sodium hydroxide that we're going to rinse with. We are going to pour it into our setup. And now, to fully and properly condition this pipette, you're going to loosen the clamp until you can take your setup out. And then what you're going to do is you're going to gently tilt the setup on its sides in order to coat the walls of the syringe and to coat the walls of your container with the solution. Then, once that has completed, you're going to drain the solution completely. You're going to then refill part of your buret with a small volume, no more than about 2 or 3 milliliters. This is known as conditioning, and it removes water from the surface of your buret, as well as it ensures that any solution added does not get diluted or altered in concentration. So we're going to take our second aliquot, pour it into our setup. Okay, now that we have that all taken care of, what we're going to do is we're going to swirl this solution around to continue to condition our buret. Okay. And now what we're going to do is we're going to fully secure our setup, and we're going to allow our solution to drain. So let's completely drain our solution. Allow me one moment. And once we've drained our conditioned buret, we'll resume in a second. Okay, so now that we have our conditioned buret, what we're going to do is we're going to fill the syringe while it is closed with our sodium hydroxide solution. We are going to fill it all the way to the 20 milliliter mark, roughly. So let's carefully fill it so the meniscus touches the 20 milliliter mark. And in order to account for air bubbles, we're going to fill it a little bit above the 20 milliliter mark and then let it drain. So we fill it over the 20 milliliter mark, and now we're going to allow it to drain Going to allow it to drain by very carefully opening the stopcock until the meniscus is at the 20 milliliter mark. Okay. There we go. So now, as we can see, the bottom of the meniscus is almost exactly at the 20 milliliter mark at eye level. So now we are ready to begin the first phase of our titration. So, in order to get things prepared, we're going to need to clean up a few of our 100 milliliter beakers. So let's get out our 100 milliliter beakers. Let's make sure we have a nice clean beaker for this next part. Okay, so before we started this lab recording, before we started this laboratory recording, we prepared and we got our pH meter fully calibrated. So let's open up our pH meter, turn on our pH meter, and now we're going to rinse our pH meter with deionized water. And in order to check that our pH meter is working properly, we're going to verify that our pH meter is functioning by immersing it in a solution that has been standardized, that is a buffer solution at pH 6.86. So if everything is going okay, when we immerse it in this test solution, we should see 6.86 roughly. So it's about 6.8. So our calibration has held up pretty well. So now we're going to rinse off our pH meter and allow our pH meter to dry. Just be really gentle with the drying step. Okay, so now what we're going to do is we are going to measure the pH of our sodium hydroxide solution. And in order to do that, we are going to pour 10 milliliters of this sodium hydroxide into a beaker. Okay. We are then going to record the pH of this sodium hydroxide solution using our pH meter. So here's our pH recorded with our pH meter. We may try to recalibrate and retake this measurement. This is the pH of our prepared sodium hydroxide solution measured using our pH meter. Okay, so now let's rinse our pH meter off. Let's clean it with deionized water and then allow it to dry. Okay, so now we have our solution. And what we're going to do is we're going to place our pH meter into this sauce solution. And we're going to record the pH of this solution. So here's our reading for the pH of our sauce solution. Initially, let me just mix this solution gently. And now let's take our reading. So we see we have a pH of about 4.42 initially for our solution. So now we're going to place this setup. We're going to place our setup under our buret. So now we have our pH meter, our buret, and our taco sauce solution. And what we're going to do is we are going to very carefully record the pH every 0.5 milliliters. And from our plot of pH versus volume of sodium hydroxide added, we will be able to determine the equivalence point and end point. So we have our initial pH value of 4.44. And now what we're going to do is we are going to very carefully add half a mil, so half a tick of sodium hydroxide, and record the pH. Okay, so we're going to open up the stopcock now and allow. Now we just want to go down half a tick. So you're going to very carefully open up the stopcock. Okay. So zooming in on our view, we're at about the halfway mark between our ticks. So now let's mix the solution. Let's allow it to mix a little bit. I'm just going to swirl the solution. And now we're going to record the pH. So for our second pH reading after our first 0.5 milliliters, our pH is 4.81. Okay, so let's keep going. And let's do our second half a mil aliquot. So now we're going to the next line. And if you have a stray drop, what you can do to get that stray drop out is you can get a small volume of water and just carefully spray. There we go. Okay, so now what we're going to do is we are going to swirl our solution. Okay. And now let's record the pH of our solution. So let me swirl this solution. And now let's immerse our electrode once again. And let's record the pH after our second addition of sodium hydroxide. So that gives us a pH of 4.86 after we've added 1 milliliter. Okay, so let's just write that down in our data sheet. Okay, so now let's add our second aliquot. So we're going to go to the halfway mark between our second tick. So let's rinse in that second little stray drop. Okay. So as you can see, looking at our buret, we are halfway between our two marks. So we've added 1.5 milliliters. And now let's mix our solution. And now let's record the pH of our solution. And the pH after our addition of our 1.5 mils is 5.28, 5.27. Yes, increments of 0.5 mils. So let's add our second. Let's add our second aliquot. And again, let's rinse this little droplet down. You want to make sure all the drops are going into the bottom of your beaker. So now let's mix. And then let's immerse. Okay, after the addition of our second aliquot, let's mix this thoroughly. Have a pH of 5.28. Okay, let's now add our another aliquot. Okay, so we've added another aliquot. Let's stir this solution. And now let's record the pH. So our pH after addition of 2.5 mils is 5.60. The pH without anything, I believe, would someone like to provide a comment for that? The pH without anything added was 4.40. Okay, let's continue on and let's add 3 mils. Okay, let's now swirl our solution. Okay. And now let's record the pH. After 3 mils, we have a pH of 6.17, or sorry, 6.16. Okay, let's add our additional aliquot of 0.5 mil. Okay, let's swirl our solution. And now let's record the pH. So our pH after 3.5 mils was 7.90. Okay, let's now add another aliquot, another 0.5 mil. Okay, so now let's swirl the solution. And now let's record the pH. In this case, the pH after 4 mils, or 4.0 to be exact, our pH is 9.55. Would someone like to remind me, what was the pH of sodium hydroxide roughly? What was the pH of sodium hydroxide? About 12.2, yep. Okay, so let's add another 0.5 mil. Okay, now let's stir our mixture. Okay, now let's immerse it in. And now our pH after 4.5 mils is 10.33. Okay, let's keep going. Let's now add our 5th milliliter. Okay, let's now stir this solution. And now let's record the pH. After our 5th mil, our pH is 10.72.
Hi, Professor.
Yes.
Is it okay if we accidentally added too many milliliters of sodium hydroxide?
As long as you record the exact volume that you add, that's okay.
Okay, thank you.
So let's add another 0.5 milliliters. Okay, and let's rinse this drop down with a little bit of DI water. Okay, let's now swirl this solution. And let's now record the pH. So now our pH after 5.5 milliliters is 11.15. Okay, let's add another half a mil. Okay. Now let's swirl our solution. Okay, now let's check the pH. So now after 6 milliliters, our pH is 11.26. Let's keep going with a few more additions. Let's add another half a mil. Okay. Now let's swirl the solution. And now let's record the pH. After 6.5 mils, our pH is 11.46. Okay, let's do another half a mil. Okay, let's now swirl the solution. Okay. So after 7 mils, our pH is 11.56. We're almost done with this. Now a little bit more. Now another half a mil. Okay. Now let's swirl the solution. And record the pH. So after 7.5 milliliters, our pH is 11.65. And let's do another half a mil just for completion. Our pH is pretty much leveled out now. Okay. Okay. And now after 8 milliliters, our pH is 11.71. So we've completed the titration of our hot sauce sample. Now, looking at any additional data that we need to collect, we've collected all of the data for this experiment. We're now going to continue on. After cleaning up this setup, we're going to do our laboratory discussion and talk about how to process this data to assign the equivalence point for this titration. And then from the equivalence point, we'll talk a little bit about how to process this data further in order to calculate the concentration of acetic acid in the hot sauce packet. Okay, so we'll clean up and then we'll discuss the calculations.